Hello, everyone. I'm Jain. I lead an AI engineering pod on the business systems team at OpenAI. Today, I'm going to talk about sense, reason, act safely, the runtime controls for enterprise AI agents. More specifically, this is about governing AI agents that do more than answer questions. A lot of early AI adoption focused on response quality. Is the answer accurate? Is the reasoning useful? Or is the model grounded? Those things still matter. But in enterprise workflows, the risk changes once an agent can call tools, trigger workflows, write a system of record, or prepare actions for humans to approve. At that point, the question is not only did the model give a good answer, but the question becomes was the action authorized, traceable, recoverable, and safe? So, this talk is a practical control model for agents that act. I'll focus on 8 ideas: classify tools, scope identity, validate output, persist state, make writes deliberate, retain evidence, bind human review, and control change. My goal is to give you a framework you can use when evaluating or designing agentic systems. Not just how they reason, but how they behave safely once they are connected to the real tools and the real workflows. So the core claim is simple. The security boundary has moved from answer to action. When an AI system only produces text, the main risks are things like hallucination, misinterpretation, or bad advice. But when an agent can execute, the action path becomes the security surface. The action path includes identity, that is, who is asking, authority, what are they allowed to do, state, what has already happened, and evidence, what can be proved later. This is essentially important in enterprise systems. Why? Because the agent is often sitting between a user and a system of record. It might touch procurement, approvals, finance operations, support workflows, contract workflows, or internal platforms. So the control model has to govern the execution path, not just the model output. One thing I've learned from production agent work is that the first thing to break is often not the model, it is the surrounding ecosystem. A request times out, state is lost between the workers. A retry creates a duplicate write. The agent has broader authority than the user expected. Debug logs capture payloads they should not capture. Or a human approval exists, but it is not actually bound to the final payload. In all of these cases, the model may have reasoned correctly. The failure is in the execution boundary. That is the mindset shift. We should not treat governance as only a model eval problem. We should also need to treat it as a distributed systems, security, and workflow control system. The first control is tool classification. Not every tool call deserves the same control path. For instance, a read-only tool that fetches status is different from a tool that drafts a journal entry. And both are different from a tool that actually writes to an ARP system. A useful pattern is to classify tools by what they can change. Read tools can observe, draft tools can prepare proposals, reviewed writes can execute only after approval. Bounded automation can perform low-risk actions inside a narrow scope. High-impact writes can change official records and need the strongest controls. Once you classify tools this way, the control path becomes clearer. You can decide where authorization is required, where validation happens, where duplicates matter, where audit logging happens and what gets logged, what needs review, and what evidence must be retained for future purpose. The key is that governance should follow the action, not the UI label. The second control is identity. For enterprise agents, identity cannot disappear after the user prompt. Every tool call needs a traceable actor, authority, and a trust boundary. There are multiple identity patterns. Sometimes the action is user to system. Sometimes it is system to system. Sometimes one app is calling another app. Sometimes the agent is acting with delegated authority. Those are very different cases. For example, if an agent reads from one system and write to another, we need to know whether the write is happening under the user's authority, a service account, or a bounded delegated permission. That matters for access control, auditability, and incident responses. This is where OAuth scopes are back and policy gateways become central. The agent should not become a shortcut around permissioning. It should carry permissioning throughout the workflow. The third control is validation before action. Tool classification tells us what control path should apply. Validation is where that path gets checked before execution. For an agent, the important question is not only whether the model gave a good answer. The question is whether the proposed action is authorized, whether the policy gateway allows it, whether the payload is still the same payload that will be reviewed, and whether the evidence will be retained. This is why validation sits before the write. It gives the system a chance to check the proposed action before it changes the state. When the action is high impact, validation should connect to the review. If the payload changes after review, the system should recheck before executing. The fourth control is persistent state for long actions. A lot of enterprise actions do not fit inside one synchronous request. They may call slow systems, wait for validation, poll for status, or require a human decision. In a real user invoked experiences, the timeouts are very rare. If work can outlive the request, the system needs an explicit job model. That usually means submit, durable state, poll, and fetch. Submit validates the intent and creates a durable job. Durable state stores that status, owner, blockers, and progress. And then poll lets the client or agent check what is happening and what had happened. And finally, fetch returns the final result and the evidence. This also helps in multi-worker environments. If submit goes to one node and poll goes to another, state cannot live only in memory. It needs to live in a shared durable store. So security value is important. Observable state, safe retries, worker independence, and reviewable delayed actions. The fifth control is write once with idempotency. What does it mean? For writes, retries should resume the same intent, not create a new one. This is especially important with agents because users may not know whether something was submitted. A request may time out. UI may not update. The user may click again, and the agent may retry, and a worker may restart. Without that idempotency, those normal failure modes can become duplicate rewrites. A practical pattern is to create an intent key. The key should represent the actor, the target, the action, a reasonable time window. Then you keep an action ledger. The ledger tracks that action was submitted, validated, written once, and the evidence was saved. This matters most for the system of records. If an agent writes to finance, procurement, approvals, or any official workflow, try again cannot mean create another real world action, but it should carry or persist the idempotency key or the ID associated with the intent that started from the user and should carry forward throughout the whole workflow. The sixth control is retaining evidence separately from the logs. Now, engineers need observability. Auditors need evidence. Those are related, but they are not the same thing. Operational logs should help debug behavior. correlation IDs, tool names, status, latency, redacted error categories. But those logs should not casually capture sensitive payloads. For high impact actions, you may need a restricted evidence packet instead. That packet can capture who requested the action, why it was needed, what tool was called, what checks passed, who reviewed it, what was written, and what proof was retained. The access pattern should be different for each of these things. Broad logs are for operations. However, restricted evidence is for audit and investigation. So the rule I like is log behavior broadly, preserve action evidence very narrowly, often use break class mechanism for the raw payloads so that if you want to debug, you have some control over it, but it's not shared broadly. The seventh control is human review. Human approval is not enough by itself. The approval must bind to the exact action that gets executed. A weak workflow shows a summary to a human, gets approval, and then allows the agent or system to recompute or mutate the payload before writing. That creates a gap. The human approved one thing, however, the system may execute something else. A stronger pattern is proposed action, human decision, recheck, write. The proposed action should be concrete. Human decision should apply to that proposal. Before writing, the system should recheck whether the payload changed, whether the permissions still hold, and whether the approval is still valid. A review gate is real only if the approved payload is the payload that gets executed. The eighth control is change control. In traditional software, we treat code that changes seriously. But in agentic systems, behavior can change through many other artifacts. A prompt change can change the output behavior. A tool schema change can change the call contract. A connector change can change the system boundary. A permission change can change authority. A workflow routing change can change where work goes. All of these should be treated as release artifacts. That does not mean every change needs a heavyweight process, but it does mean we need defs, owners, gates, and rollback paths. If an agent can act, then prompts, schemas, connectors, permissions, and routing are not just configurations, they are part of the whole control surface. This is the practical checklist I would use before launching an agent that acts. Before launch, classify the tools, define the identity boundary, confirm authorization, and add validation gates. During execution, use durable job state, idempotency keys, clear job paths, and human reviews wherever needed. After execution, retain evidence packets, keep logs safe, reconcile writes, and maintain a change record. This checklist is intentionally simple. The point is not to create paperwork, but the point is to make sure that the system can answer basic questions. Who acted? Were they allowed? What changed? Was it reviewed? Did it write once? Can we prove it later? If the system can answer those questions, it is much closer to being production ready. I will close with this. The model can reason, but the execution boundary must govern. As agents move from answering question to taking decision, we need to classify tools, scope identity, validate output, persist state, write once, retain evidence, bind human review, and control change. This is how we make enterprise agents useful without making them uncontrolled. The future of enterprise AI is not just the smarter models, but it is better system around those smarter models. Systems that are authorized, observable, recoverable, and auditable. Thank you.